Los Angeles is slowly sliding toward San Francisco at roughly the speed your fingernails grow. Given about 15 million years, the two cities could end up right next to each other. Here's the fault line making that happen. The San Andreas Fault runs for roughly 200 kilometers through California, marking the boundary between the Pacific Plate and the North American Plate. Unlike most of the dramatic plate boundaries around the world, this isn't a place where plates are colliding or pulling apart. It's a transform boundary, where the two plates are grinding sideways past each other. The Pacific Plate, which carries Los Angeles and the California coast west of the fault, is moving northwest relative to the North American Plate, which carries San Francisco and the rest of the continent. Because the motion is horizontal rather than vertical, this type of boundary doesn't build volcanoes the way subduction zones do, but it does something else instead. It builds up enormous stress. That stress accumulates because the fault isn't smooth. Friction locks sections of the fault together even as the plates on either side keep trying to move. Rock on both sides bends and strains elastically, storing energy, sometimes for decades or centuries, without actually slipping. This is called elastic strain, and it can't build up forever. Eventually, the accumulated stress overcomes the friction, holding a locked section together, and the rock suddenly snaps back into a less strained position, releasing that stored energy in seconds as an earthquake. This process is called elastic rebound, and it's why the same fault can stay quiet for long stretches before releasing all that pent-up motion at once. The 1906 San Francisco earthquake is the most famous example, when a single rupture along the fault shifted the ground by as much as 6 meters in places. Because different sections of the San Andreas lock and release on different schedules, seismologists watch particular stretches, called seismic gaps, that have gone unusually long without a major rupture, since they're storing strain that eventually has to be released. The fault hasn't stopped moving since it formed around 15 to 20 million years ago, and it won't stop now. It's simply a visible seam where two enormous pieces of the Earth's crust are permanently sliding past one another. If you want to understand how the world's landscapes were really made, subscribe for more landform explainer videos.